Hey friends, this is me, Vishwas, and I'm the host of the kind of a series that we started out where we wanted to educate you about the data engineering and not just data engineering itself. We wanted to educate you about our experience in dealing with some of the problem statements that we had, as well as giving you that kind of an insight which Akash is carrying from his experience in the industry, various firms, various platforms. I think there's a lot that I can learn from him, and this is an humble attempt from my side to understand most from him. And I welcome you all for the series. Thank you so much, Akash, for being on the show. Means a lot.
Hey, thank you. That's very warm, Vishwas. I think thank you for the welcome. So, guys, we are going to talk about new and interesting things as we go along. Today's
Yeah.
conversation is going to be around Spark, and probably even the next conversation is going to be around Spark. There's lot of things that we can talk about in Spark, and today is going to be more of a general conversation into what Spark is, what it does, what is it good for, what are the use cases, how can you get started, and things like that. So we'll just touch upon Spark. No code conversation will happen. We are mostly going to touch through the features of Spark and explore some of its capabilities. So that's what we have in today for you, Apache Spark, and a great conversation.
Yeah, I think Spark is huge. Spark is humongous.
Yeah, totally,
You
totally.
can't learn it in a day. You can't learn it in a day. If you can learn it in a day, sorry for that. You're in a wrong tutorial. You're in a wrong production environment, and that's
Yeah.
it. That's a simple intro that I wanted to start. So let's start with the first question. Could you provide an overview of Apache Spark and its impact and the significance it has brought in the big data space as well?
So I think that's a huge question, right? So we'll touch upon significance, but let's just try and understand at a high level what Spark is. So Spark now has become a unified engine for doing data analytics. It has a variety of capabilities, numbering from doing data engineering, doing data science, doing machine learning. A lot of infrastructure stuff is also taken care by Spark. So it's a unified engine and kinds of brings a lot to the table. You can just to probably go on a different tangent, you can bring your batch data, you can bring your streaming data, you can work with SQL, you can work with machine learning, you can work with a variety of programming language. So in a nutshell, I would say Spark is a good high level wrapper that available in a lot of languages like Python, Java, Scala, R, and it's an highly optimized engine that does all sorts of computational performance, all of that. So it's a very feature rich, I would say, higher level of tool set that we have, and largely used for doing in memory computation. What is incomplete computation? Sorry. Yeah. So that's what is Spark, and the what was the second part of the question? The impact, right?
Impact and the potential it has brought in the big data and data
Yeah,
engineering.
I think it's very very significant. Spark's ability to handle in-memory processing and the ability to work with a wide variety of data tasks such as processing, which can be doing batch processing, stream processing, doing machine learning, doing graph processing, and at the same time it provides an amazing set of APIs for different programming language that is just humongous. And when you look at big data ecosystem, the ability to handle hundreds of gigabytes and terabytes of data, Spark just excels at it, and it really makes it very easy because it can also be deployed on a wide variety of hardware platforms as well. You can have a vanilla installation of Spark, you can have Spark running on a Kubernetes cluster, you can have managed Spark by most of the cloud providers. Databricks is a great company that has revolutionized use of Spark. So in general, also with the advent and hype that the machine learning has brought in, Spark is right now in a very very prominent shoe. So the whole big data ecosystem has been largely touched by the capabilities it brings from a computational perspective, and it kind of goes well, right? It goes really well with different kinds of other engines like Hadoop, Hive, and Kafka. I think it gels well with different engines. Do you want me to show your screen in the screen? on the page.
I think that's for the data lake question. I was just getting ready for that one data lake question.
Sure, sure, sure.
So yeah, so I think you just gave an overview about how the compute engine is being optimized. I think Dask is kind of good, but I think probably Spark is maturing over a course of time. I think batch processing, there's a lot of improvement that's been coming out there. So what's your views on those, like the evolution of the Spark engine that we are seeing right now?
So, so, so I think Dask and Spark both are different frameworks meant for different things. Dask is a great framework if you want to scale and your use case is just scale. Dask is framework agnostic largely, uh, has very similar overlaps in form of computing like Spark, but doesn't offer the wide variety of flexibility that Spark has and the ease of use that Spark has. You can run something in Dask on your machine and scale it to clusters, but Dask doesn't offer you something like a Dask ML. You have to rely on other libraries. Spark is more of a complete ecosystem on its own. Dask still has to rely on other frameworks to provide the capability. So it's good and bad situation. So if, for example, if you want to bring TensorFlow models into Spark, it's relatively difficult, but I think with Dask you can do it. But if you want to do Spark ML like scale capabilities on raw infrastructure, you can leverage Dask and all. So different use cases, I would say. Interestingly, I think I was talking to somebody today who was, we were discussing Ray and Dask, and just as a framework from a scale perspective. So maybe that's another video we can talk about. The frameworks in machine learning that are meant for scaling. So yeah, that's what I'll say between them.
Sure. I think there is a lot of key features that we have to understand between Apache Spark compared to other big data framework processing engines. So what are the key features that you feel that Spark as one of the framework makes a differentiator with respect to other frameworks that are coming out in the market right away?
I think there's a lot of in-memory processing happening, but in general, that's the USP of Spark. So Spark stores the data in memory, and it allows the engine to access the data at a much faster level than it was if stored on disk. And Spark also does uses a variety of optimizations to achieve performance like pipelining, caching, and the DAGs are managed completely by Spark engine. There's a lot of fault tolerance and reliability baked into Spark. For example, there's this feature called checkpointing, which is Spark can checkpoint the data in memory or onto disk. So if there is a failure, it can recover by starting from the last checkpoint. There's a lot of replication happening across the nodes. So if Spark can replicate data across multiple nodes, and it will allow Spark to continue processing even if there's a node failure. Then there's a lot of fault tolerance built into it, right? Because it's a distributed system by design, it is fault tolerance. But it can do lineage tracking, things like speculative execution, and there's some advanced techniques which Spark relies to offer fault tolerance. So Spark in general, I think, uh, is extremely good at being robust, is at great speed, and with this it gives you scalability, and the APIs, that the way it has been designed, it's very flexible. It makes it good for general purpose computing like data processing tasks, but can be also used for almost real time analytics and graph processing. So yeah, those are some of the capabilities, and I think also Spark relies on the core in-memory data set. What's that called? That's RDDs, right? Resilient or data disk or something. And these are like immutable data sets that can be split and processed in parallel. That's the fundamental unit of compute in Spark, and as I think I already mentioned pipelining and caching, which it already does. So there's a lot of under the hoods that Spark has, which allows it to be I would not say superior, but be good at what it does, and be very robust at what it does.
Sure. I think you always told about like what Spark as an in-memory compute capabilities. That means, over a course of time, everybody relied on how batch processing was, but today it's all stream processing. Probably there are tons and tons of data which is coming up. But then, batch processing has been one of the most crucial element for any of the system that I consider right now today, because it can be millions and millions of bytes of data which is coming up per second. You are supposed to batch or bucket somehow it is. So let's just start with this question of how does the Spark, the feature of in memory computing capability, contribute to the speed and the performance of any processing engine as well as any batching engine that we consider today.
So I think the whole Spark doesn't differentiate if the underlying data structure is RTDs. So you have a lot of how do I go about defining this? So see, in memory in Spark refers to the ability to store and process in memory rather than disk. That's very very simple. Now in memory processing is done through RDDs, and RDDs, as I mentioned, are immutable data sets. Now you can use RDDs in a variety of different ways. You can do memory only, you can do memory and disk configuration, you can do uh, disk only configurations, and you can do serializations also with memory and disk kind of configurations. So if your RDDs are large or small, you can decide different storage levels based on that. So if you have a batch use case where you have a very large data coming in, then you should and also you only want to use it once, then you can do probably disk only, which is to say that it will work with a storage level on disk. These are advanced configurations that you can do basis your use case to optimize them. If you have some kind of let's say a real time use case, so you want to do memory only if the RDD is small, and it will be used more frequently. So the idea is that irrespective of whether you have a real time use case or you have a disk batch use case, you have the same data structure, which is RDD, to effectively help you manage the computation. And then depending on the use case, you can add storage levels to each by as I just mentioned, memory, disk only, serialized, all of that, to be able to get the best optimal performance. So that's one of the ways by which you can uh, I think design your Spark jobs nicely.
I think we are just learning the just a tip of an iceberg. It's not even close to what happens in production. But I think there is a lot that goes behind when we talk about fault tolerance in a system like Spark. I think Spark has been so humongous in terms of giving us that feature of fault tolerance. How does the feature of fault tolerance come up into the picture when we think Spark as one of the frameworks that we are trying to adapt and bring out in our production right now?
I think fault tolerance is the ability. There's certain capabilities that the system has which helps in achieving them. One is simply that it is distributed. It is a multi-node architecture, so that's there. That helps you build resilience from an infrastructure standpoint. There is replication, which is, as you have RDDs, they are replicated across different nodes in the cluster. This means that if one worker node falls, the RDDs can still be accessed, from a different worker node or something like that. There's typically a process which is sort of like an election. So let's say that there's multiple copies of an RDD, and you want to decide which is the leader, which maintains the leading position, which not leading position, leading node for that given RDD. There's sort of an election process that happens, which gives the fault tolerance. Then there's checkpointing, and Spark can checkpoint to persistent storage, meaning if nodes fail, it will pick up from the disk. So there's variety of techniques. You can always use replication and checkpointing, as I said. You can also simply have a reliable cluster manager. You can have Zookeeper do the cluster administration. I think that's Zookeeper only, or something else, maybe Zookeeper only, I think. Do your cluster management, which can help you build a good resilient Spark cluster. Even if some underlying node fails, that's more at the infra level. And you know, on a much simpler level, you can just monitor, right? You can always monitor your applications to get an understanding of how they are behaving and bake fault tolerance into it. So yeah, that's a bit on fault tolerance.
Yeah, I think just a final question. We can discuss about data lakes. I think I've had an window open already. I think it should be up now. Oh God.
You want me to
Live
share your
streaming is,
screen?
yes, I think that would be perfect.
Which one? There are two screens.
Two screens. I think there is only, this is
This
the
one?
one. This is the one. Yep, that's the one. I think data lakes has been lot of Azure data lake is something that I've been working towards. But I think what really has stuck me very hard on this making of slide was very tough for me, to be very frank with you. So RDM, MDM, PIM, DAM, whatever you think about, there's a lot of processing engine. There's a lot of,
These are just lot of good words.
yeah. But just say me some of the best parts about, like, where does Spark ecosystem fit in when we just talk about data lakes as one of the practices today?
I think from a data lake standpoint, you want to one way you can leverage Spark is when you get the data. If you have streaming sources, you can obviously use Spark to get the data and store it into HDFS. That's a very no-brainer use case. If you have large bulk data movement and bulk transformations that you want to bring in, things like unstructured data, heterogeneous data, like which is a variety of different formats, and God knows what, you can use Spark to move around because it goes really well with different kind of storage formats, and that's one way to look at it from a lake perspective. From a consumption perspective, obviously there are use cases if you want to consume data, like on the using data. There's a lot of use cases. You can use Spark ML and things like that. But what you have in here, MPP database, you can actually build an MPP database in Spark. The Delta Lake conversation is growing very nicely. And from MPP you can take it to in memory and processing tier. So somewhere in the processing tier and SQL capabilities, I think Spark can be used. At least in
Yeah,
this diagram.
I think I think yes, that's true. That's true. There's a lot that we can talk about when it comes to the potential of Spark. I think we talked about a lot about integrations, but let's just conclude the discussion about how is Apache Spark's discussion that can also be turned into with respect to the integrations that is coming up with, right? All the frameworks, all the other technologies that is coming up as an integration to the Spark right away.
So I think Spark can be integrated by a variety of other technologies and frameworks. You can have Hadoop, Hive, Kafka. There's native integrations for these. There's different sorts of file formats: Apache Arrow, Parquet, H5. Different file formats are supported. Delta Lake is natively supported. So there's a wide variety of ecosystem that Spark has. It works nicely with pandas in recent libraries. There's in recent changes, I think UDFs have picked up nicely. There's a nice framework called Apache Superset, which is used for visualization. So for BI, it does, Tableau, Dash, DBT is there, data, which is Databricks tables. Power BI is there. There from a visualization perspective. From a storage and infrastructure perspective, I think it does with everything under the hood. You have Elasticsearch, Mongo, Kafka, Delta Lake, Kubernetes. I already mentioned. I think I forgot to mention Airflow. Cassandra is there, and then there's more formats and engines that it supports just natively. So there's Spark is very very nicely, I would say, integrated. It has a great community support, and that's what I think it makes a great framework.
Sure, I think. I think let's conclude this part one because we don't want it to drag that much, and also it becomes a lot for me to draw over a course of time. Sketch notes coming soon, folks, but wait for a bigger discussion that we want to start in the community. I think there is something we have planned, something that we are planning right now. I think that's coming out soon. And thank you so much, Akash, for being on the show. Means a lot.
Thank you, Vishwas. Bye bye, everyone. Just a big shout out if you have not subscribed to my channel, which is Cafe IO, do subscribe to it. Thank you, guys. Bye bye.
Thank you so much.